During the 20th and 21st centuries, humans on Earth consumed mass amounts of fossil fuels, which over time led to climate change and global warming. In the early 21st century, the warming oceans led to the melting of the polar ice caps and subsequently the rising of the sea level, causing many humans in coastal areas to perish. In the fifth decade of the 21st century, global warming got so bad that humans were forced to leave Earth due to super hurricanes that were wreaking havoc across the planet. But that was 150 years ago. Today, we find ourselves in a new situation on Mars. Similar to 2014 Earth, we see that different people have formed their own countries and communities on Mars.
By the way, how's your Maths IT 20 class going so far? I bet it's very interesting.
Pretty good, actually. The teacher's really cool.
Hey guys, how are you doing?
Hey, Rachel.
Look what I found in Professor Tamhane's office. It looks like one of those things that we used to call USBs.
Professor Tamhane? I think she was one of the first researchers on Mars.
I wonder what's on there.
Whatever you want.
Yes, I've already.
Hello, my name is Dr. Perlmutter, and I am a part of the team selected to bring power to Mars. Today's date is December 10th, 2050, and it's been around a week since we had to leave Earth. My team and I are part of the University of Michigan at Mars community, and a 120,000 person research community here on Mars. Our task over the past week has been to develop a sustainable power source that can produce around 1,766 gigawatt hours per year. Over the next several minutes, my team and I will explain how this happens.
Hi, my name is Dr. Tamhane, one of the researchers here on Mars. So far, our solar panels have been able to withstand the temperature here. We're located right below the ice cap of Planum Boreum, which is our north pole, and therefore the average temperature is around -5 degrees. So we get around 18 hours of sunlight per day. Because of the dust storms here on Mars, the solar panels are conical in shape. So not only does this help us with our dust, but it optimizes the amount of sunlight that is absorbed. They're 9 times more effective than the conventional panels, and we prefer to use gallium arsenide to the silicon wafers for them due to their 44% higher efficiency and low density, which allowed us to manage our payload during our historic launch in 2050. Additionally, our energy is stored in lead-acid-based batteries that are kept indoors to prevent corrosion.
Hi, fellow space travelers. I'm Abrar Fiaz, one of the chief engineers responsible for designing the electrical power infrastructure for our community on Mars. The whole project is divided into 2 main divisions, the power generation and power storage systems. Our community on Mars will be powered through 69,000 solar cones made of gallium arsenide solar cells that are spread out on an area of about 28,000 square meters to meet a requirement of 201.6 megawatts. To store power for use at night, we have created a well-established power storage system comprised of over 1,600 lead-acid batteries, with each unit storing around 2.4 gigawatt hours for 20 hours.
Hi, I'm Angela Hu, the Chief Manufacturing Engineer. I'm responsible for manufacturing close to 70,000 gallium arsenide-based solar cells. Our fabrication process reuses the parent wafer, minimizing a large portion of manufacturing costs. These solar cells would still cost around $200 each. However, the thin structure and high efficiency make gallium arsenide a prime candidate. This patented process begins with crystal growth. The next step of cold weld bonding attaches gallium arsenide to a flexible base. The surface of the wafer can then be cleaned and prepared for another cycle of crystal growth. The solar cells are then shaped into cones and attached atop carbon fiber solar tree structures and wired to the lead sulfuric acid batteries. Voila! Energy for our colony.